In this talk, I am going to explain the concept of zValue, the concept of standard variable, and how do we take a random variable from its current form into its standard form, into its z form. As usual, I have created some numbers here which are random. They are changing. The reason that I make these numbers random is because it will enable us to solve several problems, but more importantly, it will help us to separate the solution procedure from the data, the modeling tool from the data. Therefore, if our modeling tools are sound, if our modeling tools are correct, they can perform on different sets of data. If I want to take these numbers from its current form to their standard form, one question that I usually need to answer is, which one of these are greater than average and which one are less than average? That is one step to take these numbers from their current form towards the standard form. So I come here in this cell, I type equal to this number minus its average, and because I'm going to copy to the right and copy down, I lock it, push F4, and it is locked. This number, the difference between that number and average is positive, and that means the number is greater than average. Copy to the right, copy to the bottom. Let me tell you how I painted these cells, automatically painted them. First, I remove rules. Then I come here, conditional formatting, highlight. If it is greater than 0, if this number is greater than 0, means the actual number was greater than average. And in that case, for example, paint it green. Then I use format painter, and I format the rest of the cells based on the same rule. Those which are greater than average are green, the rest are white. Now I want to know how many of these numbers are greater than average. So it says equal to count if what? These numbers, the range that I am considering is quotation mark greater than 0, and close the quotation mark, close the parenthesis, then you have 33. So 33 numbers are greater than 0, now it's 31. Then I get this number divided by count all of them. So 36 numbers were greater than 0, and they are 57% of my observations. Here are 44, 50. Now one other step that I need in moving towards translating random variables into their standard form, into their z form, is to know what are these values. 473, 1253, negative 1279. But what are these? I need to standardize them. How do I standardize them? By dividing them by standard deviation. So I go over there, I type equal to standard deviation of sample, and I get these numbers. Now I have the average and I have the standard deviation. I can go here, equal to the difference between the random number and its average divided by standard deviation. And then because I'm going to copy to the right and to the bottom, I need to lock the standard deviation. Enter. About 1 standard deviation less than average, about 2 standard deviation greater than average, about 0.65 standard deviations, less than average, and then I copy it everywhere. How did I paint them like this? I go and remove rule, then I go mark them, conditional formatting, I go here. For example, if I click on this, in this situation, if a number is large, it becomes red. If it is small, it becomes green. But I want the reverse, so I can go this way or this way. Now in this format, negative numbers are red and positive numbers are green. And the more positive the number, the more green. And these numbers are telling me how much these random numbers are greater than average or less than average. By how much, I mean how many standard deviations. For example, this one is 1.14 standard deviation greater than average, and this one is 1.25 standard deviation less than average. If I compute the average of these numbers, it should come out 0 because I have got each number and subtract it from the average. The last thing I want to mention is Chebyshev theorem. Chebyshev theorem says if we go k standard deviation to the right of average and k standard deviation to the left of average. For example, if we go 3 standard deviation to right and 3 standard deviation to left, then at least 1 minus 1 over 3 to the power of 2. 1 minus 1 over k standard deviation that we have gone to the left and right to the power of 2 squared. At least that percentage of the random variable is covered. But this theorem is correct if k is greater than 1. So I have 1.1 and here I have set equal to this one plus 0.1, and then I have gone down over there. Then here I have said, okay, that probability is equal to 1 minus 1 divided by this one squared. If I go 1.5 standard deviation to the left and right, at least 55% of observations are there. And if I go 2 standard deviation to left or right, at least 75% are there. We know that in normal distribution, if we go 2 standard deviation to the left and 2 standard deviation to the right, about 95% of the observations are covered. And if we go 3 standard deviation to the left and right, 99.73 or something very close to that would be covered. Now, given this original data, I use this formula, random variable minus its average, to find it out if it is greater than average or less than average, divided by its standard deviation. I want to copy them to the left and right and bottom. I need to lock average and lock standard deviation. By subtracting from average and divided by standard deviation, we know that the random variable is how far from the average in positive or negative direction, and that is how many standard deviations. That is what we got, and these are the numbers we have here. Now we want to know how many of these numbers are 1.1 standard deviation to the left or 1.1 standard deviation to the right. So I go here, I use this function, and what you see here is less than or equal to this one. So it's less than or equal to 1.1, and it is greater than or equal to minus this one. So it is true. This one is between negative 1.1 standard deviation and positive 1.1 standard deviation. If I copy it to the right and copy to the bottom, some of these numbers are within that range, negative 1.1 and positive 1.1 standard deviation, and some of them are out of that. If they are within that range, if it is within that range, put 1, otherwise put 0 and enter. Okay, now 1, 1, 0, 1, 0, and so on and so forth. And if I count them, equal to count if, select the range. If that one is equal to 1, count it, divided by count. So that is count of those which are in that range divided by overall count. And that would be 71. How I painted this one, I will go over there again to conditional formatting. Clear the rule. Conditional formatting. New rule. Use formula. If this number, and then I remove those absolute values because I'm going to format paint it. If that number is equal to 1, then format it green. Okay, okay, and it's green. Now I go and format paint it and apply to all. And apply to all. So now if it is 1, it is green. Then I go here, again I say conditional formatting, new rule, use a formula. I go here and I click on this, again F4, F4, F4 to make it relative. If that is equal to 0, then paint it red, okay, and okay. And then format paint and apply it everywhere. And my friends, thank you very much for your attention. See you in class.